Okay, so last week we talked correlation, you saw scatter plots, you saw the strength of the linear relationship in graphed data in those scatter plots. Today we're going to model that data with regression lines. So let me just start off with a random scatter plot. Okay, I'm going to erase that one. So last week we found we graphed, right? This is some data that we graphed, and we found an R value, and we did that by hand. Today we're going to do that in the calculator. Something else we want to add to this is we want to model the data using a regression line or a line of best fit. Okay, so what that means is we're taking this data and we're trying to basically summarize it into a single equation, in this case, a linear equation. So I'm going to sketch this. Let's see, I think the line of best fit would probably be something like this. Okay. What makes a line the line of best fit, or what makes a regression line is that the difference between the line graphed and the data points is very, very small. They're called residuals. So basically what I'm saying is, let me get a different color. Wherever the line is and wherever the data point is, we want that difference to be as small as possible. That's what makes a good regression line, okay? And we're going to do so today. We're going to use that today. So regression line, it's an equation that can be used to predict the value of y for a given value of x. What does that mean? That means model the data. Best models the data. Best models the data. That's what that means. Okay. And that if it best models the data, then we can use that to predict values. That's one thing that's really great about regression lines. Okay. So this is a better picture than what I just drew, but here you have these little solid dots. Those are the data. Okay. Those are the observed value. The observed value means the data. Okay. Then the model is the line of best fit is the model. And so that would be the predicted data, predicted y values, and we want that difference to be as small as possible, okay? That difference is called the residuals. We want that to be as close as possible so that way it best models the data. The residuals can be positive, they can be negative, but ideally we want them to be as small as possible, and 0 would be best because that means we would have the best model because those values would equal up, they would be the same, and I have that right here. Okay, so if the observed y value equals the predicted y value, then the difference is 0, and the difference is the residual. Okay, to figure out the line of regression, we use the sum of squares of all the residuals, and it's going to be a pretty intense formula. So let's go ahead and look at that. So, So here's another definition. The regression line, the line of best fit, is the line for which the sum of the squares of the residuals is a minimum, okay? But really, it's nothing different than what you already know. We are using y equals mx plus b, okay? M is the slope, and if you remember, it's rise over run. Okay, if you remember from geometry or algebra 1, it's y2 minus y1 over x2 minus x1. And then b is the y-intercept, okay? And it is where the y-intercept is where the point crosses the y-axis. If you remember from algebra, okay, you use 2 points to determine the equation of a line, right? You'd be given like 1, 2, 3, 4, and you would use those 2 points to find the slope. You could use those 2 points to then plug in values into the slope-intercept form and find the equation, okay? But in statistics, we need every point. We need to consider every single point. So it's a little bit different, okay? So down here is where it gets a little bit more intense. So we're still using the same equation, okay? But we don't say y equals anymore. This means y hat. This is pronounced y hat, That's how you pronounce it. So y hat equals mx plus b. Okay. M is still the slope, b is still the y-intercept, but this is how we're gonna find it. Okay, using this lovely formula. Okay. It's pretty much the same formula that we did last time. Okay. And then we have our y value. Okay. Y bar minus x times x bar, and then they have it broken down even further. So the sum of the y over n minus the sum of the the sum of the y over n minus the slope times the sum of the x over n. Okay, and the regression line will always pass through x bar comma y bar. Y bar is the mean of the y values, and I circled over the next definition. X bar is the mean of the x values. Okay, so that is how we find the linear regression. But I'm not going to make you do it by hand. We're going to go straight to the calculator. So the next video will be going over how to find the regression line in a calculator and also the R value in the calculator.